Good morning everyone, hope you all safe with a good health. With you is Dina Al-Badri, science teacher for grade 8. Today we'll complete our lesson electromagnetic spectrum, how much of the sun's energy reaches us. Most of the sun's energy is in the narrow visible light range, but the sun gives off some radiation in every part of the spectrum. Not all wavelengths of the light penetrate the atmosphere equally. Radio waves penetrate the atmosphere easily. Some electromagnetic radiation can be dangerous to humans, so we take extra steps to protect ourselves. Ultraviolet lights can be harmful. It can penetrate the clouds. In space, the dangers from electromagnetic waves are very higher because there is no atmosphere to filter the radiation. So in the space, we have to take more protection, more precautions to protect ourselves from the harmful radiation, because there is no atmosphere, there is no atmospheric layer in the space. But on Earth's planet, we have atmospheric layer which protect us from the harmful radiation and make filtration. We take the harmless and the atmospheric layer prevents the harmful radiation to penetrate the clouds. Different frequencies of electromagnetic waves carry different amount of energy. High frequency electromagnetic waves have more energy than low frequency. So again, high frequency electromagnetic wave have more energy than low frequency electromagnetic wave, because low frequency such as radio wave carry less energy. They are safer and because low frequency waves such as radio wave carry less energy, so they are more safer. So baby monitor using radio waves. So if you want to use a wave or something in manufacturing, LED, television, mobile for children's, we use radio wave because they has less energy, so they are more safe. High frequency wave such as ultraviolet light carry more energy and can be harmful. Ultraviolet light causes sunburns, and X-ray require precautions. Okay, so the high frequency wave like the ultraviolet light and X-ray, it need more precautions to protect ourselves from this high frequency waves. Near the poles, the acceleration particles form an aurora that can light up the sky. Okay, we talked about the aurora phenomena. It's happening in the North Pole and South Poles. The accelerated particles from an aurora that can light up the sky. The aurora at the North Pole is called the aurora borealis. At the South Pole is called the aurora australis. Okay. We will watch a video about the aurora phenomena especially. Okay, the color of the aurora depends on the type of the atom in the atmosphere that react with the solar wind. Okay, that's all. I hope you all understand. Next time, inshallah, we will solve a question or worksheets about this lesson. You will watch a video about the electromagnetic spectrum and another video about the aurora phenomena.
On Arctic nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts. On the Sun, a star of average size among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.